Now, very often when we study sequences, we like to know how the sequence behaves in the long run. Does it fluctuate all the time, or does it damp out in some manner? So this means that we want to study the limit of this sequence. Now let us first define what we mean by limit. And this is in fact definition 2 of the book, section 9.1. We formulate it a little bit less mathematically. So let us consider a sequence of numbers an, and we say that it converges to the number L if the following happens. If an is arbitrarily close to L for all indices n large enough. So the larger n grows, the less we can distinguish an from this limit L. Now we write, in this case, the limit for n tending to infinity of an equals L, and what we say is that the sequence of numbers an converges. Now if this limit does not exist, then we say that the sequence diverges. Okay, let me give a few examples. So suppose that an is equal to 1 over n, then if we look at the limit, of course, n becomes larger and larger, and we divide by a larger and larger number, so we get 0, and so we have a convergent sequence. Now the next example is an equals minus 1 to the power n, and what you see in that case is that an is equal to 1 or minus 1, and it continues to fluctuate between the two values, and so the limit cannot exist. There's no number L that is approached by an sufficiently closely. And this sequence is therefore divergent. And in the calculation of limits, you can use the same techniques as we used for calculating the limit for x tending to infinity of a function f of x. Now let us give me one example of that case. So suppose that an is equal to n squared plus 2n plus 1 divided by 2n squared plus 3, for instance. Then, as we did with functions, we divided by the largest, the highest power. And the highest power occurring in this fraction is n squared, so we divide everything by n squared, and what we get in that case is the following thing. Then in the numerator, we dividing by n squared by n squared gives us 1, 2n divided by n squared gives us 2 over n, and 1 divided by n squared gives us 1 over n squared. 2n squared divided by n squared gives us 2, and 3 divided by n squared gives us 3 over n squared. And if we now send n to infinity, you see that all terms except for this 1 and this 2 disappear, and we get 1/2. So this is a convergent sequence. You also have to know some standard limits, which may come in quite handy, and these are the following three limits. If we send n to infinity in the sequence of numbers given by 1 plus some number a divided by n to the power n, then this converges to e to the power a. Now the second one, which we will use later on, that if we have a number x smaller than 1 and we raise it to the power n and consider the limit for n tending to infinity of this expression, then what we get is 0, because if we think of x being equal to 1/2, for instance, then if we raise 1/2 to a higher and higher power, the number becomes smaller and smaller, so we get 0 eventually. And the third one is that if we divide x to the power n by n factorial and we send n to infinity, then the n factorial in the denominator grows much quicker than the x to the nth of the numerator, and so we get 0 in the limit.